A stone that moves by itself challenges the very ground beneath our feet. Our planet hides landscapes that seem to defy the rules of nature, places where geology feels more like magic or ancient artistry. In this journey, you will discover the truth behind 25 of Earth's most baffling rock formations, gaining a new understanding of the strange and beautiful forces that shape our world. How did massive stones carve perfect paths across a desert floor, and what keeps a giant boulder balanced on a pinpoint for millennia? These are not just curiosities, they are profound puzzles written in stone. Are you ready to question what you think is possible? A truly unexplained rock formation does more than simply look unusual. It presents a question that our current understanding of geology struggles to answer. The criteria for this kind of mystery often involve a combination of factors that feel improbably precise. Take the natural process of erosion, for example. Wind and water typically wear away stone in chaotic, uneven ways, creating the rugged, organic shapes we see in most mountains and canyons. So when we discover a landscape dotted with near-perfect spheres, or a cliff face etched with a grid of right angles, it immediately gives us pause. These are not the fingerprints of random chance. Similarly, a formation might be made of a mineral that has no business being in that location, or geological dating might suggest it is far older or younger than the surrounding rock layers should allow. Expert geologists are the first to apply a principle called Occam's razor, which suggests the simplest explanation based on known processes is usually the right one. Yet they are also the first to admit when a formation stands in defiant silence, resisting every conventional model put forward. This careful distinction is what separates a rare geological oddity from a genuine enigma. By first understanding the established rules of how our planet shapes itself, the exceptions we are about to explore become not just strange but profoundly significant. They are the outliers that hint at forgotten processes or perhaps at stories written in stone that we are only beginning to decipher. The most compelling mysteries are often those that happen right in front of us, yet remain invisible. In the heart of California's Death Valley lies a stark, flat expanse called the Racetrack Playa, a dried lake bed so barren and silent it feels like the surface of another world. Scattered across this pale clay are hundreds of rocks, some as large as a household refrigerator, and behind each one, a long, graceful trail is etched into the earth. These are the legendary sailing stones, and for generations they presented a puzzle that seemed to defy logic. Heavy stones do not simply get up and walk. Yet the evidence was undeniable, curving tracks stretching for hundreds of feet, sometimes making sharp 90-degree turns, as if the rocks had decided to go for a leisurely, meandering stroll. The absolute silence of the place deepened the mystery. No human had ever seen a stone move. For over a century, this led to wild speculation. Could powerful, localized magnetic fields be pulling them? Were mischievous spirits or, as some suggested, extraterrestrial visitors rearranging the desert floor as a prank? The truth, as scientists eventually discovered, was both more ordinary and more extraordinary. It required a perfect, fragile recipe of natural events. During cold winter nights, a thin sheet of ice forms on the playa from rare rainfall. When the morning sun warms the surface, this ice begins to fracture into large, window pane-like sheets. A gentle breeze, just strong enough to catch these floating panels of ice, can then push against a rock trapped within the ice, causing it to slide slowly across the slick, wet mud below. The movement is incredibly slow, perhaps just a few inches per minute, and happens so infrequently that capturing it required years of patient observation and time-lapse photography. So the mystery is solved, right? Not entirely. While this ice raft theory explains many of the tracks, some of the largest stones and their most complex, looping paths still challenge the model. The precise balance of ice thickness, wind speed, and mud consistency needed to move a 600-pound boulder remains a topic of study. The sailing stones stand as a powerful reminder that even when we find an answer, nature often reserves a final whisper of uncertainty, a testament to the delicate and violent poetry of simple physics pushed to its limit. From the silent, sliding stones of a desert, we travel to the roaring edge of an ancient ocean. Northern Ireland's Giant's Causeway presents a spectacle so geometrically perfect it feels deliberately crafted. Here, the wild Atlantic crashes against a shoreline paved with roughly 40,000 stone columns, most fitting together in a stunning honeycomb of hexagons. This is not the work of a stonemason, but of a volcano. The legend, however, speaks of a giant. Irish folklore tells of Finn McCool, a colossal figure who built this stepping stone path across the sea to confront his Scottish rival Benandina. It is a story born from pure awe, a human attempt to explain the seemingly impossible artistry laid out across the coast. Science gives us a different, yet equally magnificent, origin story. This is columnar jointing, a phenomenon that occurs when a thick layer of lava cools slowly and uniformly. As it contracts, it fractures, creating a network of cracks that propagate downward, much like mud drying in the sun. The result is often these polygonal columns, with 6 sides being the most efficient and stable shape for the fractures to take. The process itself is understood. Yet the Giant's Causeway remains a profound mystery because of its sheer scale and order. This is not a small cluster of columns. It is a vast, interlocking pavement that stretches into the sea. The uniformity is startling, each hexagon appearing as a piece of a colossal, natural puzzle. Volcanologists note that this represents a geological perfect storm. It required a lava flow of just the right chemical composition, spreading at just the right thickness over a perfectly flat plateau, and then cooling at an exceptionally steady rate over centuries. Any significant variation in these conditions would have created a chaotic, broken landscape of uneven pillars. Instead, we are given a masterpiece of symmetry. This formation quietly challenges our deepest assumptions about randomness in nature. We expect the Earth's creative forces to be wild and untamed, yet here they have produced a pattern of such mathematical elegance it borders on architecture. The Giant's Causeway stands as a permanent question etched in basalt, asking us to reconsider where the line truly lies between a chaotic natural process and a work of art. The ambition of the ancients is carved not only into their triumphs, but into their failures. In the sun-scorched quarries of Aswan, Egypt, a different kind of mystery lies sleeping, one of human intention frozen in stone. Here, partially liberated from the rose-red granite bedrock, rests the unfinished obelisk. It is a staggering sight, a single piece of stone intended to rise over 10 stories tall and weigh more than 1,200 tons. This is not a natural formation, yet it presents a geological puzzle of a different order, a direct challenge to our understanding of ancient technology and its limits. The mystery is not how the stone got there, but how they ever planned to get it out. Surrounding the colossal form are the clear marks of the workers' tools, simple dolerite pounders, which are just handheld stones harder than the granite. With only these, teams would have sat for months, perhaps years, pounding a trench around the intended obelisk to free it, a testament to almost unimaginable patience and coordinated labor. The logistical puzzle deepens from there. Once freed, how would they have levered this mountain of stone from its bed? How would they have transported it hundreds of miles down the Nile without it sinking the barges? And how would they have erected it with perfect precision? The scale of the operation implied by this single abandoned project pushes the very boundaries of what we believe was possible in the Bronze Age. Its abandonment is the final layer of the enigma. A prominent crack runs through the granite, a flaw that likely made the monolith unusable for its sacred purpose. In that moment, a project of decades was simply walked away from, leaving a perfect snapshot of advanced quarrying technique halted in mid-stroke. This site is a haunting monument to human ambition, a reminder that the past holds not just answers, but profound questions about the forgotten scale of our ancestors' dreams and the silent, stony evidence of where those dreams met their limit. Buried treasure is a dream that fades quickly in the harsh light of a jungle workday. In the 1930s, as workers for the United Fruit Company cleared land in Costa Rica's Diquis Delta, their machetes struck something far harder than a tree root. They began to unearth smooth, round stones, some small enough to hold, others larger than a car. Disappointment must have followed the initial excitement, for these were not chests of gold, but something far more perplexing. These were the stone spheres of Costa Rica, and they presented a riddle of craftsmanship that has only deepened with time. Scattered across the landscape and sometimes buried in ancient sites, over 300 of these spheres have been found. They range from the size of a grapefruit to colossal orbs over 2 meters, or roughly 6.5 feet in diameter, weighing many tons. The material itself, usually a hard stone like gabbro or limestone, is not the mystery. It is the shape. The precision is what stops you. Many of these spheres are so geometrically perfect that their diameter varies by less than 2% from a mathematically ideal sphere. In an age without precision laser tools or digital calipers, this level of accuracy seems almost supernatural. How do you carve a perfect sphere from solid rock using only stone hammers and abrasives? Experts in archaeology and experimental geology have proposed a method. It likely began with selecting a large boulder and using fire to heat the surface, making it brittle. Then, artisans would have painstakingly pecked away at the stone with other, harder rocks, gradually roughing out a rounded form. The final, breathtaking symmetry would have been achieved through a marathon of grinding, using sand and water as an abrasive, perhaps rotating the sphere slowly within a cradle or against another stone. This process represents an investment of time and communal effort that is staggering to contemplate, for a single large sphere might represent years, even decades, of continuous labor. This immense investment points to a purpose of profound importance. The spheres were not hidden away, they were placed with clear intention. Many were found arranged in lines, triangles, or parabolas, often leading to or encircling the homes of important individuals or their final resting places. Some alignments correspond to celestial events, like the solstice sun or important stars, suggesting they functioned as a kind of astronomical calendar or a map of the cosmos, connecting earthly power to the heavens. Others might have marked territorial boundaries or sacred spaces. Yet, the people who made them, part of the complex pre-Columbian chiefdoms of the region, left no written records to explain their work. The meaning of these arrangements, the specific stories and beliefs they encoded, died with their creators. Today, the spheres sit in museum courtyards and overgrown fields, silent and inscrutable. They are a testament not to a lost technology, but to a lost language of stone, a code of perfect geometry whose message we can only guess at, reminding us that some of history's most beautiful questions are the ones that remain stubbornly, elegantly unanswered. Sometimes the greatest trick nature plays is on the mind itself. High on the desolate lay Kargil Highway in Ladakh. A stretch of road offers an experience that feels like a glitch in reality. Here, drivers are instructed to stop their car at a specific painted marker, shift into neutral, and release the brake. To their utter disbelief, the vehicle begins to roll, not downhill, but seemingly uphill, defying the most basic law of gravity they have ever known. This is the magnetic hill, and for centuries, this visceral, disorienting phenomenon convinced travelers they had found a place where the world's fundamental rules had simply stopped working. Local legends spoke of mountains with such powerful magnetic force that they could pull metal objects upward, or of divine intervention that protected the sacred landscape. The mystery felt absolute, a direct challenge to human perception and scientific understanding. The truth, however, lies not in the pull of magnetism, but in a perfect conspiracy of landscape. This is a classic gravity hill, a masterclass in optical illusion. The surrounding Himalayan terrain creates a profound visual deception. The true horizon line is completely obscured by towering, overlapping mountains and ridges. What the driver's eye perceives as the upward slope is in fact a very slight downward incline. The surrounding scenery is tilted in such a specific, convincing way that it overrides the body's own sense of balance and perspective. Geomorphologists note that for this illusion to work with such power, it requires a precise and rare alignment. The road must sit in a bowl-like valley, with all visual reference points, like distant trees or the line where sky meets land, artfully hidden or misleadingly angled. The brain, desperately searching for a stable horizon to orient itself, latches onto the only available cues, which are all lying to it. The result is a profound sensory betrayal. You are rolling downhill the entire time, but every neuron in your visual cortex screams that you are climbing. This formation presents a different kind of mystery, one that was solved not by discovering a new geological process, but by understanding the profound vulnerabilities of human perception. It stands as a humbling monument to the gap between what is and what we believe we see, reminding us that the Earth's greatest puzzles are sometimes not written in the stone beneath our wheels, but in the intricate wiring of the mind that attempts to understand it. The line between solid earth and surging water vanishes completely in the Australian outback. Here, a wall of stone does not simply stand, it flows. This is wave rock, a 15-meter-high, 110-meter-long cliff of multicolored granite that has been sculpted into the perfect, curling form of a monstrous ocean wave, frozen at the very moment it is about to crash. It looks like a petrified tsunami, an instant of unimaginable hydraulic violence captured and turned to stone for millennia. The visual effect is so powerful, so dynamically fluid, that your mind rejects the stillness. You can almost hear the roar. Geologically, this is a textbook example of a flared slope. The process begins not with wind or rain on the surface, but with water percolating downward through the soil. Beneath the ground, where the granite meets the earth, a chemical reaction occurs. Groundwater, slightly acidic from decaying plant matter, slowly eats away at the base of the rock, dissolving minerals and undercutting the cliff face over countless centuries. Later, when the surrounding topsoil is stripped away by erosion, this sculpted, curved underbelly is revealed. The process itself is mapped and understood by hydrologists, who can point to the unique composition of the granite and the specific patterns of water runoff in this arid landscape as the precise architects of this form. Yet, understanding the recipe does not diminish the awe of the final dish. The mystery and defiance of wave rock lie not in an unknown process, but in its breathtaking aesthetic perfection. The probability that such a slow, subterranean chemical weathering could produce a shape of such dynamic, artistic elegance feels vanishingly small. It is as if the rock remembered a moment from its molten past, when it truly did flow like liquid, and decided to echo that memory in its solid age. This formation stands as a profound monument to patience. It demonstrates how the slowest, most invisible forces, given enough time, can mimic the most fluid and transient of natural phenomena. Wave rock blurs a fundamental line in our perception, asking us to see the ocean in a mountain, and to recognize that even the most solid and permanent things are, in the grand scale of the planet's life, merely in a state of incredibly slow motion. Deep within the silent, moss-draped forests of Finland, Time holds its breath around a single, impossible moment. Here rests Kummakivi, a name that translates simply to strange rock, and it is a masterpiece of natural suspense. An enormous boulder, the size of a small van, balances with breathtaking delicacy upon a smooth, rounded dome of ancient bedrock. The point of contact between the two is astonishingly small, no larger than a dinner plate, creating a visual tension so profound it feels as if the forest itself is waiting for the stone to finally fall. The air is still, the only sound the distant call of a bird, amplifying the sheer improbability of the scene. This is not a formation that shouts with grandeur, but one that whispers a relentless, quiet question. How is this even possible? Geologically, the broad strokes of the story are clear. This landscape was sculpted by the colossal continental glaciers of the last ice age, which acted like slow-moving rivers of ice, scraping up bedrock and carrying immense burdens of stone across hundreds of miles. As the climate warmed and these glaciers retreated, they deposited their cargo in chaotic piles known as glacial till. Kummakivi is a classic glacial erratic, a traveler from a distant place. The mystery is not its journey but its arrival. The retreat of a glacier is not a gentle setting down of objects. It is a messy, violent process of melting and collapse where rocks are dropped haphazardly into mounds of debris. For a stone of this immense weight to settle onto a specific, curved bedrock pedestal with such impossible precision defies every expectation of that chaotic process. It would be like dropping a grand piano from a great height and having it land perfectly balanced on a single crystal glass. Glaciologists can map the meltwater channels and the retreat patterns, but the flawless equilibrium of the final result remains a captivating statistical anomaly. Local folklore, sensing this defiance of ordinary physics, filled the gap with a narrative of immense strength. Tales speak of mighty giants or clever trolls carefully placing the rock as a testament to their power, a story born from the human need to attribute such perfect balance to conscious artistic intention. Kummakivi stands as a humbling counterpoint to our view of nature's raw power. It suggests that within the brute, chaotic forces that shape continents, there exists the potential for moments of startling, delicate grace. This balancing giant is a permanent question mark in the woods, a demonstration that even the most violent chapters of Earth's history can occasionally leave behind a signature of perfect, silent calm. The forest's quiet balance gives way to the rhythmic crash of an ocean that sculpts a different kind of wonder. On New Zealand's wind-swept Cocoa Beach, the shoreline is guarded by an army of stone giants. These are the Moeraki boulders, enormous spheres scattered across the sand, as if a race of colossal beings had abandoned a game of marbles. Some sit half-buried, emerging from the cliffs like ancient eggs waiting to hatch. Their appearance is so deliberate, so artfully round, that the human mind instinctively rejects the idea of random chance. Long before geologists arrived with their explanations, the Maori people of this land wove the stones into their origin stories. They speak of the great canoe Araturu, which was wrecked upon this coast long ago. The boulders are said to be the petrified remains of the gourds and sweet potatoes that washed ashore from that legendary vessel, a poetic explanation that roots these mysteries in a narrative of journey, loss, and the gifts of the ancestors. This cultural story offers a profound layer of meaning, transforming the stones from oddities into landmarks of memory, connecting the physical landscape directly to the community's historical identity. Science provides a different, yet no less marvelous, origin story that spans millions of years. These are concretions, not simply rocks shaped by waves, but creations born deep within the earth. They began their existence on an ancient seafloor over 60 million years ago. In the soft, muddy sediment, minerals like calcite began to slowly precipitate from the surrounding groundwater, crystallizing layer by microscopic layer around a central core. This core could have been anything: a fossilized shell, a piece of wood, or even a fragment of bone. The process is akin to the way a pearl forms inside an oyster, with mineral material accumulating in concentric spheres over an immense span of time. What makes the Moeraki boulders a genuine geological enigma, however, is their startling perfection and scale. Concretions are common worldwide, but they are typically lumpy, misshapen, and relatively small. The boulders on Cocoa Beach defy that norm utterly. They can reach over 3 meters or nearly 10 feet in diameter and possess a spherical symmetry that rivals machined precision. Furthermore, their surfaces are etched with a beautiful, intricate network of cracks known as septaria. These fractures formed later as the concretions dried and shrank, often filling with secondary minerals like yellow calcite or brown dolomite, creating a stunning turtle shell pattern. For geochemists, the mystery lies in the specific alchemy required to produce such objects. The conditions had to be just right: a perfectly consistent supply of mineral-rich water, a stable chemical environment, and an absence of any disturbance for millions upon millions of years. Any shift in pressure, temperature, or sediment composition would have resulted in an irregular form. The sheer size indicates a rate of growth and a duration of stable conditions that are exceptionally rare in the geological record. These boulders, then, are not just rocks. They are natural clocks and chemical diaries recording an epoch of profound patience and environmental consistency. They stand as monumental evidence that the natural world, through the silent, relentless work of chemistry and time, is capable of producing works of geometric art that rival any sculptor's dream. They challenge our perception of randomness, showing us that within the chaos of earthly processes, there exists a potential for breathtaking order, written in the slow language of mineral precipitation, and revealed only when the sea finally pulls back the curtain of sandstone and mudstone that hid them for so long. Far from the crashing ocean and sunlit beaches, the earth holds its most astonishing treasures in absolute darkness. In the year 2000, miners drilling deep within the Rica silver mine in Mexico broke through a wall and flooded their tunnel with a searing, humid breath from a hidden world. They had accidentally discovered the Cave of the Crystals, a subterranean chamber that feels less like a geological feature and more like the sacred heart of the planet itself. Here, colossal beams of selenite, a transparent form of gypsum, stab through the gloom. Some are over 12 meters long, the length of a school bus, and weigh more than 55 tons. They lie in chaotic, beautiful heaps, intersecting at impossible angles, creating a forest of luminous stone that glows with an internal light when illuminated. The environment is as alien as the crystals are beautiful. The air temperature hovers near 58 degrees Celsius with humidity at 100%. A human without protective gear would succumb to heat stroke in less than 30 minutes, their lungs filling with a superheated fog that feels like breathing liquid fire. This is not a place for life as we know it. It is a kiln, a pressure cooker that has been sealed for 500,000 years. The sheer size of the crystals presents the central, breathtaking mystery. How does a crystal grow to such monstrous proportions? The answer is a story of geological perfection, a recipe of such precise and unwavering stability that it borders on the miraculous. The cave sits atop a deep magma chamber, which heated groundwater saturated with calcium and sulfate minerals. For hundreds of thousands of years, this mineral-rich water filled the cavern, kept at a constant, steamy temperature of exactly 54 degrees Celsius. At this specific thermal point, the mineral anhydrite, which is dissolved in the water, begins to convert into gypsum or selenite. This conversion process is incredibly slow, depositing molecule by molecule onto a growing crystal face. What made Rica unique was the unwavering consistency of the conditions. Expert mineralogists note that even a minor fluctuation in temperature or a change in the mineral concentration of the water would have stopped the growth or produced smaller, imperfect crystals. The chamber remained perfectly sealed, a natural laboratory where the experiment ran undisturbed for millennia. This is the true enigma of the Cave of the Crystals. It is not a mystery of an unknown force, but a profound demonstration of what happens when the chaotic Earth holds perfectly, impossibly still. The crystals are not just objects, they are a physical record of deep time, each millimeter of growth representing centuries of patient, invisible accumulation. They showcase a hidden, slow-motion artistry that operates on a scale human ambition can scarcely comprehend. The cave represents a phenomenon so rare, requiring such a fragile and enduring alignment of heat, chemistry, and solitude, that it is unlikely we will ever find its equal. It is a cathedral built not by hands, but by the planet's own patient molten heartbeat, a reminder that the most magnificent wonders are often those we were never meant to see. From the searing darkness of a crystal cave, we ascend to the silent, sun-bleached expanse of the Sahara. Here, the Earth itself seems to have opened a single, unblinking eye. Known as the Richat Structure, this colossal feature in Mauritania is so vast it can only be truly comprehended from the void of space. For astronauts orbiting high above, it appears as a perfect 50-kilometer-wide bull's-eye etched into the desert, a series of concentric rings that stare skyward with an almost unnerving symmetry. This is the eye of the Sahara, and for decades its origin was a textbook mystery. Its sheer circular perfection screamed one obvious answer: a cataclysmic impact from a massive asteroid or comet. Yet when geologists searched the site for the telltale signs of such an event, like the mineral-shocked quartz formed under immense pressure, they found nothing. The ground was not shattered in the right way, and the center of the structure was strangely, impossibly flat. The impact crater theory evaporated under the desert sun. The prevailing explanation today is one of monumental patience and collapse. Geologists now believe the Richat structure is a deeply eroded geologic dome, a giant blister on the Earth's crust that formed over 100 million years ago when molten rock pushed the overlying layers upward into a broad, gentle arch. Over eons, wind and water stripped away the softer rock layers, leaving behind the more resistant bands of quartzite and igneous rock to form the prominent, concentric ridges we see from orbit. The process is understood in theory, but the result continues to baffle. This is where the genuine mystery takes root. While erosion can certainly carve rings, it almost never does so with such breathtaking geometric perfection. Natural erosion is a chaotic artist, favoring jagged canyons and uneven mesas. The Richat structure, by stark contrast, displays a near-flawless circularity and symmetry that defies the typical, irregular shapes of other eroded domes around the world. Its isolation on a featureless plane only heightens the effect, making it appear as a deliberate, colossal mandala pressed into the planet's surface. The puzzle is one of scale and precision, a question of how the forces of uplift and decay could have collaborated to produce something of such immense, ordered beauty. This striking appearance has inevitably sparked imaginations far beyond the field of geology. Some researchers and enthusiasts, noting descriptions from the philosopher Plato, have controversially speculated that the Richat could be the location of the lost city of Atlantis. They point to its circular design, its location beyond the Pillars of Hercules, and the presence of ancient river channels suggesting a very different, greener past. While mainstream archaeology finds no evidence of such a civilization there, the speculation adds a powerful layer of historical longing to the site's geological wonder. It transforms the formation from a mere rock structure into a symbol, a canvas upon which we project our deepest stories of a forgotten golden age. Whether a natural masterpiece or a sunken legend, the Eye of the Sahara remains an indelible landmark. It challenges our understanding of erosion's artistry, and stands as a permanent reminder that our planet is still capable of presenting vistas so perfectly strange they blur the line between a natural process and a profound, silent message. A monolithic puzzle rises from the American plains like a petrified giant. Devil's Tower in Wyoming is a geological declaration, a sheer-sided column of rock that ascends 1,267 feet into the sky, visible for miles in every direction. Its surface is a breathtaking network of deep, vertical cracks, creating the appearance of massive, closely packed columns. This place holds a dual legacy, sacred and cinematic, that deepens its inherent mystery. For many Native American tribes, including the Lakota, Cheyenne, and Kiowa, this is not a tower, but a place of profound spiritual power. Oral histories speak of its creation in a time of need, where the Great Spirit caused the rock to rise, saving people from a pursuing bear, whose claws then scored the sides into the deep grooves we see today. This story is not merely folklore, it is a living cultural narrative that connects the landscape directly to community identity, memory, and reverence. In modern times, the tower achieved global fame as the otherworldly landing site in the film Close Encounters of the Third Kind, framing it as a beacon for the unknown. Both of these layers, the ancient and the modern, recognize the same fundamental truth that this formation is utterly singular, a focal point for wonder that transcends explanation. The scientific mystery is not whether it is volcanic, that much is clear from its composition of phonolite porphyry, a rare, light-colored igneous rock. The puzzle lies in the precise volcanic process that could create such a solitary, symmetrical masterpiece. Was it the hardened magma that once filled the central vent or neck of a long-vanished volcano, with all the surrounding cone eroding away? Or was it a laccolith, a blister of magma that intruded between layers of sedimentary rock and never actually reached the surface? Perhaps it was a volcanic stock, the remnant of a much larger underground magma chamber. Each model has its proponents among expert volcanologists, and each struggles to perfectly account for the tower's dramatic isolation and the stunning uniformity of its columnar joints. The columns themselves are a marvel of natural engineering, formed as the thick mass of magma cooled slowly and contracted, fracturing into these polygonal shapes. Yet the scale and order here are exceptional. The columns are remarkably straight and regular, some of the largest and most symmetrical examples of this phenomenon on Earth. This suggests a cooling event of unusual steadiness and purity, a geological perfect storm where the chemistry, the temperature gradient, and the lack of disturbance align to create a natural skyscraper. Devil's Tower stands as a defiant landmark, a reminder that even when we name the rock and map the cracks, the full story of its birth remains just out of reach, an enduring monument to the beautiful complexities simmering just beneath the surface of our world. A labyrinth of stone awaits where a forest should be. In China's Yunnan province, the Shilin stone forest spreads across the land in a breathtaking panorama of gray spikes and narrow alleys. You walk not on a path but through a petrified maze surrounded by towering limestone pillars that rise like the skeletal trunks of ancient, colossal trees. The air is cool in the shadows they cast, and the silence is profound, broken only by the echo of your own footsteps twisting through the stone corridors. This is not a single formation, but an entire ecosystem of rock, a landscape that feels both meticulously designed and wildly chaotic. For over 270 million years, this was a story written not by fire or ice, but by the persistent, gentle work of water. Rain, slightly acidic from absorbing carbon dioxide in the atmosphere, fell upon a vast ancient seabed of soluble limestone. Over epochs, this weak carbonic acid seeped into cracks and fissures, slowly dissolving the rock and carving out an underground world of caves and channels. Then tectonic forces began to lift this sculpted landscape upward, bringing it into the open air, Wind and rain continued the work, eroding the softer material and leaving behind the hardest, most resistant limestone spines. This process, known as karst formation, is understood by geomorphologists and can be seen in places around the world. Yet, the stone forest of Shilin presents a mystery of density and artistry that defies the ordinary. The sheer number of spires is staggering, packed so closely together they create a genuine labyrinth. Their shapes are not merely rough columns, but are often razor-sharp, fluted, and fantastically complex, resembling everything from mushrooms and animals to mythical beasts frozen mid-stride. This level of intricate, dramatic presentation surpasses most other karst landscapes, which tend toward rounded hills or isolated pinnacles. The specific climatic history of Yunnan, with its cycles of intense monsoon rains followed by dry periods, acted like a master sculptor switching between a fine chisel and a coarse grinder, creating this unique texture. The result feels less like a natural accident and more like a deliberate, if chaotic, sculpture garden on a planetary scale. Sensing this aura of intentional, monumental force, the local Sani people, a branch of the Yi ethnicity, have long held their own explanation. Their folklore speaks of a benevolent giant named Jin who, seeing his people suffer from a terrible drought, decided to build a dam to create a lake. He tore up the earth with his mighty hands, pulling up vast sheets of stone, but was tricked and stopped before he could finish. The scattered, upright stones are the remnants of his colossal effort, a myth that perfectly captures the landscape's appearance of purposeful, unfinished destruction. This cultural story does not contradict the science, but layers it with human meaning, transforming a geological wonder into a monument to altruism and ancestral struggle. The stone forest stands as a testament to the creative power of dissolution, a slow, liquid force that can, given enough time, carve a masterpiece of bewildering complexity and silent, stony grandeur. Precision is a ghost in the Nevada desert, leaving only sharp, angular signatures in the dust. At Little Bonnie Claire Playa, a dry lake bed that feels like a sibling to Death Valley's racetrack, rocks have carved their own enigmatic paths. They slide just as their famous cousins do, but here the mystery takes a decisive turn, literally. While many trails curve gently, some etch perfect right angles into the pale clay, as if the stone paused, made a calculated decision, and changed course with the crispness of a draftsman's line. This simple geometric defiance introduces a profound new layer to what we thought was a settled story. The established ice raft theory, which so elegantly explains the long, sweeping curves in Death Valley, stumbles when faced with a 90-degree pivot. Picture the proposed mechanism, a large, thin pane of ice catching the wind and pushing a rock across slick mud. For that sheet to not only move forward but to cleanly rotate a heavy stone to face a new direction without wobbling or skidding requires a set of conditions that feel improbably delicate. It suggests a moment of near-perfect balance where the force applied was not a steady shove but a precise, turning nudge. Expert geomorphologists studying the site propose fascinating possibilities. Could unique, swirling wind vortices in this specific basin catch one edge of the ice sheet? Perhaps variations in the thickness of the ice, creating a stronger leading edge on one side, acted like a rudder. Maybe the rock itself was perched on a tiny pivot point in the mud, allowing it to rotate more freely. Each hypothesis is plausible in theory, yet the crucial act has never been witnessed or conclusively recorded. No time-lapse camera has yet captured the exact moment a boulder executes its sharp turn, leaving the mechanics in the realm of compelling speculation. This formation serves as a vital, humbling reminder. It shows that solving one mystery does not mean we have unlocked all of nature's secrets, even within the same family of phenomena. The sliding rocks of Little Bonnie Claire Playa prove that the natural world is a master of variation, holding back final, perfect answers to remind us that within every explanation, there often lies a quieter, more intricate question waiting in the stillness. A giant's blade seems to have fallen from a clear desert sky. In the vast, sun-baked expanse of Saudi Arabia's Tamar oasis, the Al-Naslaa rock formation presents a site so cleanly divided it stops rational thought. Here, a massive sandstone boulder, taller than a person, stands perfectly bisected by a single, vertical fissure. The crack is astonishingly straight and narrow, like a cut made by a geological laser, leaving two halves that balance with impossible poise on their own small, natural pedestals. It is an image of surgical precision carved into a material known for crumbling and weathering in chaotic, unpredictable ways. Our minds are wired to see intention in such clean lines, making the immediate assumption that this must be the work of intelligent hands, a monument from a forgotten age. Yet the desert offers no such easy answers. Geologists approach this puzzle with the tools of known processes. The most straightforward explanation is that this is a joint, a fracture caused by tectonic stresses deep within the Earth's crust. As the ground subtly shifts over millennia, immense pressure can build up in a rock mass until it finally releases, cracking along a plane of weakness. Another common cause is frost wedging, where water seeps into a tiny crack, freezes, expands, and slowly pries the rock apart over countless cycles. Both are perfectly natural, documented phenomena. But Al-Naslaa defies these ordinary explanations through its extraordinary presentation. The mystery is not the existence of a crack, but its character. Natural rock fractures, even clean ones, typically show some slight wandering, a subtle irregularity born from the heterogeneous nature of the stone. The split at Al-Naslaa lacks this entirely. Its path is relentlessly straight, its width remarkably consistent from top to bottom, creating an almost machined appearance. Furthermore, the fact that both separated halves remain standing upright, balanced on their slender bases rather than having toppled, adds a layer of statistical improbability that deepens the enigma. Expert opinions vary, with many geomorphologists suggesting the split likely followed a pre-existing, unusually linear weak zone within the sandstone, perhaps an ancient seam where the sediment layers met with perfect flatness millions of years ago. This inherent flaw would have provided a guided path for the crack, a predetermined fault line that the forces of stress or ice simply activated. Yet, even this reasoned explanation feels stretched when confronted with the physical reality. The formation stands as a quiet, monumental challenge to our assumptions about randomness and force. It demonstrates that natural processes, under a specific and rare convergence of perfect internal structure and external pressure, can produce an outcome of such stark, clean geometry that it mirrors human craftsmanship. Al-Naslaa is a natural theorem written in sandstone, proving that the line between a chaotic fracture and a perfect cut is sometimes vanishingly thin, a reminder that the desert holds not just sands of time, but moments of inexplicable, razor-sharp clarity. The desert's stark geometry melts into a landscape of soft, repeating curves. On the Philippine island of Bohol, the horizon itself seems to breathe in gentle, rolling waves. Spread across 50 square kilometers are more than 1,200 nearly identical hills, each cloaked in vibrant green grass that transforms to a rich cocoa brown in the dry season. From a high vantage point, the sight is surreal and deliciously whimsical, an endless sea of giant chocolate truffles laid out by a confectioner of impossible scale. This is the Chocolate Hills Formation, a vista that feels less like a random act of nature and more like a pattern deliberately stamped upon the earth. The broad geological script is understood by experts. Millions of years ago, this entire region was a shallow, warm sea where countless corals and shellfish lived, died, and accumulated into a massive, thick layer of limestone on the ocean floor. Tectonic forces later pushed this ancient sea bed upward, exposing it to the elements, From that point, the patient work of erosion by rain and rivers began to sculpt the plateau. Yet here, the typical story of chaotic erosion takes a bizarre and beautiful detour. The profound mystery of the Chocolate Hills is not that they were carved, but how they were carved with such exquisite uniformity. Why would the forces of wind and water, which typically create jagged peaks, deep canyons, and irregular mesas, instead produce over 1,000 near-perfect conical domes of remarkably similar size and spacing? It is a landscape of such repetitive harmony it feels mathematically orchestrated. Geologists point to a key factor, the homogeneous composition of the limestone itself. Because the rock was formed from consistent coral deposits, it lacks the varied layers of hard and soft stone that usually lead to uneven, stair-stepped erosion. When a plateau of such uniform material is exposed, rainwater tends to dissolve it evenly, creating a pattern of sinkholes that gradually widen and deepen at a similar rate. This process, combined with the region's specific climate and drainage patterns, can theoretically lead to these rounded forms, but the sheer number of hills and their startlingly consistent conical shape pushes this explanation to its limit. It suggests a geological perfect storm where every variable, from rock density to rainfall pattern, remained unwavering across a vast area for millennia, a stability that feels almost as miraculous as the hills themselves. Sensing this playful defiance of normal landscapes, local folklore long ago crafted a more dramatic origin. One beloved tale speaks of two giants engaged in a monumental fight, hurling massive boulders and clumps of earth at each other for days. When their battle finally ended from exhaustion, they left behind the scattered, rolling hills as the only evidence of their clash. Another story tells of a giant named Arogo, who wept great tears that turned into the hills after the loss of a mortal woman he loved. These myths do not seek to explain chemistry, they explain wonder. They are born from the human need to attribute such delightful, unnatural uniformity to a story, to a moment of colossal emotion or conflict frozen in the terrain. The Chocolate Hills, therefore, stand as a dialogue between earth and imagination. They challenge the geologist's models with their gentle, persistent symmetry, while offering the storyteller a canvas of endless, identical mounds that beg for a legendary cause. They remind us that some of nature's most joyful mysteries are not about violent defiance, but about a quiet, pervasive order that makes the world feel, just for a moment, like a place of deliberate and beautiful design. Human hands can sometimes open a door that nature itself then walks through. On a remote Nevada ranch, a living sculpture breathes plumes of steam and hot water into the desert sky. The Fly Geyser is a pulsating mound of brilliant color, a structure of terraced cones painted in impossible shades of emerald green and fiery red, looking less like a part of our world and more like a landscape transplanted from another planet. Its defiance is absolute, a vibrant, noisy spectacle in a place of silence and dust. The profound mystery of this formation is not that it exists, but why it looks the way it does and how it grew so astonishingly fast. Its origin story is uniquely modern. In 1964, a well drilling operation seeking geothermal energy tapped into a pressurized aquifer of scalding water. The drillers sealed the well, but not perfectly. The pressurized water found the weak point and began escaping to the surface, carrying with it a dissolved treasure of minerals. Over the decades since, that constant hot flow has been building a new mountain. This is not the work of millennia, but of mere human lifetimes, a geological process put on fast forward. The water is rich in calcium carbonate and silica, which precipitate out as the water cools and evaporates in the desert air, depositing layer upon layer of a rock called travertine. This process creates the geyser's terraced, alien architecture, a miniature version of the processes that built the great hot spring terraces of Yellowstone over thousands of years. Yet the true, breathtaking defiance of Fly Geyser is its palette. The vibrant colors are a gift of life, not just geology. The constantly flowing hot water provides a perfect habitat for thermophilic algae, heat-loving microorganisms that thrive in the scorching runoff. Different species flourish at different temperatures, painting the terraces in bands of stunning color, from deep greens to brilliant oranges and reds. This is a living canvas, its hues shifting slightly with the seasons and the flow. For experts in geothermal systems and geomicrobiology, the site is a priceless open-air laboratory. It presents a unique, accelerated model of how mineral deposition and extreme ecosystems can co-evolve. They can observe in real-time processes that normally take centuries to become visible, watching how biology actively shapes geology by influencing mineral formation. The geyser defies easy categorization because it is a hybrid, a perfect collaboration between an accidental human act and the relentless, creative forces of nature. It stands as a powerful testament to the idea that our interventions, however unintended, can sometimes unlock a hidden, beautiful potential in the earth, creating a new kind of mystery that is both of us and utterly beyond us. Fire and water perform an impossible duet in a quiet corner of a New York forest. At Chestnut Ridge Park, a modest waterfall cascades over a shale cliff, and hidden within its shimmering curtain, a small, flickering flame dances defiantly. This is the Eternal Flame Falls, a place where the fundamental elements of Earth seem to have rewritten their own rules, creating a scene of serene magic. Water tumbles, mist fills the air, and yet at the heart of all that dampness, a tongue of fire persists, sheltered on a tiny grotto behind the falling water. It looks like a scene from a fantasy, a natural altar that has burned since time immemorial. The source of this wonder is geological, not mystical. Deep beneath the park lies the Marcellus Shale Formation, a rich layer of sedimentary rock known to hold vast stores of natural gas, primarily methane. Over millennia, geological stresses have fractured this shale, creating a network of tiny pathways that allow the trapped gas to seep slowly upward to the surface. This specific seep emerges precisely behind the waterfall, where the overhanging rock provides just enough shelter to protect the flame from being doused by the main force of the stream. The existence of a natural gas seep is, in itself, not particularly rare. What makes this site a genuine geological mystery is the perfect, fragile consistency of the flow. For a flame to burn continuously in such a damp, dynamic environment, the seep must provide a steady, reliable stream of gas, neither so weak that a breeze or splash extinguishes it, nor so strong that it blows itself out or becomes dangerous. This precise equilibrium is extraordinarily uncommon. Expert geochemists studying the site are mapping the specific fracture network in the shale, trying to understand the subterranean plumbing that meters out the methane with such clockwork reliability. The fractures must be just the right size and length, creating a natural pressure regulator that ensures a constant, gentle feed. It is a delicate natural valve that has been left in the on position for thousands of years. This formation defies our basic expectations by showcasing a stable partnership between opposing forces. It is a demonstration of how the chaotic processes of fracture and seepage can, under a perfect set of conditions, result in a phenomenon of serene balance. The flame feels like a living part of the landscape, a tiny, enduring heartbeat of the Earth itself, reminding us that the planet's most captivating wonders are often those that exist in a state of beautiful, improbable tension. Rocks are not supposed to behave this way. In a quiet Romanian village, the ground seems to give birth to smooth, rounded stones that swell after a rain, nudge themselves across the soil, and even appear to multiply. These are the trovants, a name meaning growing stones, and to witness them is to question the very definition of what is alive. They emerge from the earth like geological potatoes, some small and spherical, others oblong and bulbous, often clustering together in families that look for all the world like a brood of petrified eggs. The local folklore understands them not as mere objects, but as entities with a strange, slow vitality of their own, a belief born from direct, observable wonder. After a heavy rainfall, villagers might return to find a stone that has visibly increased in size, or discover that a familiar cluster has shifted, as if the stones had gathered closer in the night. This behavior, so eerily reminiscent of living things, is what elevates them from a simple curiosity to a profound geological mystery. The scientific explanation is a marvel of chemistry in action. Travans are a specific type of sandstone concretion, formed millions of years ago in the unique conditions of powerful seismic activity. The sand grains are cemented together not by ordinary silica, but by a rich, water-soluble limestone cement. When rainwater soaks into the stone, this cement dissolves, creating a highly mineralized solution inside. Pressure builds within the porous rock, an osmotic force that pushes the saturated solution outward toward the drier surface. There, the water evaporates and the dissolved minerals, primarily calcium carbonate, precipitate out and harden, adding a new, concrete-like layer to the stone's exterior. This is the growth, a literal addition of mass and volume from the inside out. The process is understood in principle by geochemists, who can replicate the cementation in a lab. Yet, the mystery and defiance of the Travans lie in the startling, lifelike results of this inorganic process. The growth is not uniform. It often occurs in unpredictable bulges and nodules, making older Travans look like a cluster of smaller stones fused together, a form that uncannily resembles reproduction. Some appear to sprout smaller, bud-like protrusions that can eventually separate, creating the illusion that the parent stone has given birth. Their movement, while subtle, is another layer of the puzzle. As they grow asymmetrically and shift their weight, or as the soil around them expands and contracts with moisture, they can slowly migrate over decades, leaving faint trails in the earth. This combination of growth, movement, and replication creates a powerful, almost unsettling mimicry of biology. They challenge our deepest, most static perception of stone. We think of rocks as the ultimate symbols of permanence, as anchors in a changing world. The Travans upend that completely. They present geology not as a slow, ancient history, but as a dynamic, observable process that operates on a human timescale. They are a living demonstration that the boundary between the mineral world and the biological world is far more porous and creative than we ever imagined. A quiet village secret that turns the ground beneath our feet into a stage for a slow, silent, and utterly captivating performance. Shattered perfection lies scattered across a high Bolivian plain. At Puma Punku, part of the ancient Tiwanaku complex, the ground is littered with colossal stone blocks that look less like ruins and more like the components of a giant, disassembled machine. These are not rough-hewn monoliths, but pieces of andesite and granite, some weighing over 100 tons, featuring surfaces so flat they seem polished, edges so sharp they could cut, and geometric channels carved with a consistency that feels digitally programmed. The immediate, visceral reaction is one of profound technological dissonance. This does not look like the work of Bronze Age hands with copper chisels and stone hammers. It looks engineered. The geological mystery here is not the origin of the rock, which is local, but the terrifyingly advanced method implied in its modification. How do you achieve such flawless 90-degree angles across a surface many meters long? How are intricate, interlocking T-shaped channels carved into solid granite with such uniform depth and smoothness, as if by a milling machine? The precision is not merely artistic, it is mechanical, suggesting a knowledge of mass production and assembly that feels centuries ahead of its time. Expert archaeologists and modern master stonemasons who study the site are often left in respectful silence. Replicating these cuts and finishes with the presumed tools of the era, simple bronze implements and abrasive sand, seems almost insurmountably difficult, requiring not just skill but an almost unimaginable investment of time and a systematic, mathematical approach to stonework that rivals modern precision engineering. Some blocks even show evidence of what appear to be precise drill holes, with a consistent spiral groove that suggests a tool rotating at high, steady speed. This has led to enduring debate about whether the Tiwanaku civilization possessed advanced, now lost techniques for working hard stone, perhaps involving specialized tools, compound abrasives, or a deep, forgotten understanding of stone's crystalline structure. While mainstream science attributes the work to extraordinary human ingenuity, patience, and communal effort, the sheer physical evidence at Pumapunku stands as a stark, silent puzzle in the long story of human engineering. It challenges our linear narrative of technological progress, presenting stones that whisper of a sophistication we are only beginning to fully appreciate. A reminder that the past may hold chapters of knowledge written in a language of geometry and stone we have yet to fully decipher. The stone blocks of a dismantled machine give way to a landscape of playful, petrified creatures. High on the moorlands of North Yorkshire, the Brimham Rocks Formation transforms a windswept heath into a natural sculpture garden of astonishing whimsy. Here, massive outcrops of millstone grit, a coarse sandstone, have been carved by 10,000 years of relentless wind and rain into a silent, stony menagerie. You can walk among them and find the idol, a towering pillar capped by a precariously balanced stone that seems to defy gravity with a casual shrug. Nearby, the dancing bear appears frozen mid-stride, a hulking shape that perfectly captures the lumbering posture of its namesake. Further on, the Smarty Tube stands as a hollowed-out cylinder of rock, its smooth, rounded form looking like a giant's discarded toy. This is not the chaotic, abstract erosion of a typical cliff face. Each formation feels deliberately crafted, a recognizable figure hewn from the living rock, as if some invisible, patient artist has been at work for centuries. A broad geological script is one geomorphologists can read with clarity. This landscape began as layers of sand deposited by ancient rivers over 300 million years ago, compacted into the hard, pebbly sandstone known as millstone grit. The key to the sculpting lies in differential erosion. The rock is not uniformly hard. It contains bands and nodules of softer material, and is crisscrossed by a grid of natural vertical cracks called joints. When wind-driven rain scours the surface, it attacks these weaknesses first, wearing away the softer stone and exploiting the cracks, slowly isolating the harder, more resistant blocks. It is a subtractive art where the forces of weather act as the chisel. The process itself is a textbook example of how such landscapes form. Yet, the profound mystery of Brimham rocks is not the process, but the astonishingly specific product. Why here, on this particular moor, did this mechanical weathering yield such a coherent collection of recognizable shapes? Why a bear, an idol, a watchful turtle, or a towering mushroom? Differential erosion typically creates pinnacles, arches, and strange shapes, but they are usually abstract, open to interpretation. At Brimham, the interpretations feel less like imagination and more like simple recognition. The defiance lies in this uncanny figurative quality. It suggests that within the random variations of rock hardness and the chaotic patterns of jointing, there existed a hidden template, a three-dimensional puzzle where erosion did not just reveal random forms, but revealed specific characters waiting within the stone. Expert geomorphologists point to the unique consistency of the wind direction over millennia, combined with a very specific layering within the gritstone, as the likely architects. The prevailing winds from the west have acted like a steady, unidirectional sandblaster, sculpting the rocks from one primary angle with remarkable consistency. This persistent, focused assault, working on a rock mass with just the right internal variations, may have guided the erosion along a surprisingly figurative path. The result feels creatively intentional, a sensation that has captivated visitors for generations. Long before modern geology, people saw in these shapes the work of giants, druids, or mythical beings, projecting stories onto the stones to explain their eerie resonance. This formation challenges our deepest assumptions about the divide between random natural forces and recognizable art. It demonstrates that under a perfect, enduring alignment of rock composition, structural joints, and climatic persistence, the blind tools of erosion can become, by sheer statistical wonder, a master figurative sculptor. The rocks of Brimham Moor stand not as a defiance of geological principle, but as a breathtaking celebration of its hidden potential for artistry, proving that even the most relentless forces can occasionally leave behind a legacy of silent, stony playfulness. The playful stone giants of the Moor surrender to a far deeper, more liquid dream. In the jungles of Mexico's Yucatan Peninsula, a diver descends into the crystal-clear, fresh water of a sinkhole known as Cenote Angelita. The light from the surface fades to a soft blue and the world grows quiet. Then, at a depth of about 30 meters, something impossible appears. A thick, white, swirling cloud stretches out below, looking exactly like a flowing river. Its surface is textured like moving water, and along its banks, the silhouettes of long-drowned trees and fallen leaves are perfectly preserved, creating the complete and haunting illusion of a forest riverbed buried beneath the sea. This is the underwater river, a vision so perfectly crafted it feels like a portal to an inverted world. The mind rebels, struggling to reconcile the fact that you are suspended in water, looking down at what appears to be more water, arranged into a landscape that belongs on dry land. This breathtaking phenomenon is a masterpiece of fluid chemistry, a place where different densities create a liquid ladder. The top layer is fresh rainwater that has filtered through the jungle soil. Below the phantom river cloud lies a much heavier layer of salt water that has seeped in from the nearby Caribbean Sea. Between them exists a boundary called a halocline, where the two waters meet but mix only very slowly. The ghostly riverbed itself is not water at all, but a dense, viscous cloud of hydrogen sulfide gas. This gas is produced by the decay of organic matter, like those ancient leaves and trees on the cenote floor. Because the hydrogen sulfide is slightly less dense than the salt water but more dense than the fresh water, it becomes trapped in a suspended band within the halocline, forming that distinct cloudy layer. The chemical and physical processes are mapped by hydrogeologists, yet the formation's profound defiance is not against science, but against human perception. The mystery lies in its perfect, eerie mimicry. The cloud does not just hang there, it flows and undulates with subtle currents, its surface reflecting light in a way that perfectly mimics a river's surface tension. The debris trapped within it lies along its edges like a natural riverbank. This is where nature performs a sublime act of deception. It takes a toxic, gaseous byproduct of decay and, through the precise architecture of density and light, transforms it into a mirror of one of the most comforting, familiar landscapes on Earth. It challenges our most basic categories, blurring the line between river and sea, between cloud and current, between a toxic reality and a beautiful illusion. Cenote Angelita shows us that the planet's creativity is not limited to shaping rock, but extends into the invisible chemistry of water itself, crafting scenes of surreal familiarity in the most alien of environments, as if to remind us that even in the depths, we might find a haunting reflection of the world above. The illusion of a sunken river dissolves into the vertigo of a true abyss. In the lush jungle of San Luis Potosi, Mexico, the earth simply opens its mouth. This is Sótano de los Golondrinas, the Cave of Swallows, a vertical shaft so immense and deep it redefines the very concept of a hole. Standing at its rim, you peer into a cylinder of shadow that plummets over 370 meters straight down, a depth great enough to swallow the entire Chrysler building with room to spare. The scale is not just impressive, it is physically disorienting, a pure void that seems to pull at your sense of balance. Birds, thousands of white-collared swifts and green parakeets, spiral in and out of this colossal chimney. Their morning exodus and evening return a breathtaking spectacle that gives the cave its name. Their dizzying flights only emphasize the sheer, staggering drop. The formation of this pit is a story written in water and limestone, a classic karst process. Over millions of years, slightly acidic rainwater percolated through the bedrock, slowly dissolving the soluble limestone and carving out an underground chamber. Eventually, the ceiling of that chamber could no longer support its own weight and collapsed inward, creating this monumental shaft open to the sky. This broad sequence is understood by geologists. Yet the Cave of Swallows presents a mystery of geometry and focus that sets it apart. The true enigma is not that it formed, but how it formed with such breathtaking, cylindrical perfection. Most sinkholes and pit caves are irregular, with sloping walls, debris cones, and uneven contours. This one is different. Its walls are astonishingly vertical and smooth for most of their descent, creating a near-perfect natural well. This suggests a story of remarkable geological consistency. Expert speleologists studying the site believe the key lies in a single, dominant weakness within the limestone, perhaps a perfectly vertical fault line or an unusually pure and homogeneous layer of rock. When water found this flaw, it did not wander. It focused all its dissolving power along this one precise line, exploiting it with relentless efficiency over eons. The collapse, when it came, followed this preordained vertical blueprint, resulting in a shaft of such clean symmetry it feels deliberately engineered. This formation defies our typical expectation of caves as winding, mysterious labyrinths. Instead, it presents as a monument to verticality, a demonstration of water's power not as a broad sculptor, but as a precision drill operating on a planetary timescale. It is a lesson in focused force, showing how nature, when given a perfect weakness and enough time, can create a void of such majestic and simple grandeur that it leaves the viewer with a profound sense of awe and a humbling reminder of the slow, patient power that shapes the world from the inside out. Silence is not the desert's only voice. In the vast, rolling seas of sand from the Sahara to the Gobi, certain dunes possess a hidden song. When the sand on their steep slopes begins to avalanche, it does not slide in silence. Instead, the dune emits a deep, resonant boom, a low humming musical note that can be felt in your chest as much as heard with your ears. This is the phenomenon of singing or booming dunes, and to stand before one is to witness geology transform into a living instrument. The sound is eerie and ancient, a sustained note that can last for several minutes, vibrating through the empty air like the call of a colossal, buried bell. It is a sound that has inspired legends for centuries, with travelers' tales speaking of desert spirits, hidden temples, or the groaning of the earth itself. The scientific pursuit to understand this music begins with the sand itself. Not all dunes can sing, only those composed of very specific, well-sorted grains of sand that are spherical, smooth, and within a precise size range. When a layer of these grains begins to slide, they do not tumble chaotically. Instead, they move in synchronized waves, a cascading sheet where the grains bounce and collide in a unified rhythm. This collective motion creates vibrations within the sliding layer, which are then amplified by the dry, still air and the hollow structure of the dune itself, acting as a giant resonating chamber. Expert acousticians and geophysicists can map the basic physics, identifying how grain size and slope angle influence the pitch, with finer sands producing higher notes and steeper slopes generating louder volumes. Yet the core mystery remains hauntingly beautiful. How does a process as seemingly random and chaotic as a sand avalanche achieve such perfect synchronization? It is the difference between the sound of a handful of rice poured onto a table and the rich, sustained note of a cello. The exact conditions that trigger this harmonic lockstep between billions of individual grains are still not fully predictable. Researchers study the role of minute humidity levels in the air, the electrostatic charges between grains, and the precise packing density of the sand layer. A dune that sang yesterday might remain silent today under a slightly different sky. This formation defies our deepest expectation of geology as a silent, stoic force. It reveals the landscape as a dynamic performer, capable of generating profound music through nothing more than the collective behavior of its smallest parts. The singing dune stands as a testament to hidden order within apparent chaos, a reminder that even in the most barren and timeless places, the earth holds a capacity for resonance, waiting for the right moment to share its deep, vibrating song with anyone patient enough to listen. A river of blood stains the pure white ice of Antarctica. From the snout of the Taylor Glacier, a 5-story waterfall pours a shocking, deep crimson into Lake Bonny below, a violent splash of color in the most monochrome landscape on Earth. This is Blood Falls, and its dramatic appearance is only the surface of a mystery that runs over 1 million years deep. The color itself has a chemical explanation, a dramatic reaction of iron-rich water meeting oxygen in the air, rusting instantly to create that startling hue. But the true defiance lies not in the color but in the source. This water is not melting from the glacier's surface. It is bleeding from within, flowing from a subglacial reservoir of ancient seawater that has been trapped in complete darkness under immense pressure for more than 1 million years. This hidden world defies every expectation of Antarctica as a sterile, frozen desert. It is a time capsule of liquid, a pocket of the ancient ocean sealed away by advancing ice during a warmer epoch and forgotten by the world above. The water is hypersaline, so salty it remains liquid at temperatures far below freezing, and it is utterly isolated. This isolation is what makes Blood Falls a geological and biological revelation. Within that dark, briny, iron-rich water, completely cut off from the sun and the atmosphere, thrives a unique ecosystem of microbial life. These are not simple organisms, they are sophisticated survivors that have rewritten the rules of existence. They do not rely on photosynthesis or oxygen. Instead, they perform a kind of alchemy called chemosynthesis, using the sulfate and iron minerals in the ancient rock as their energy source, essentially breathing rock and metabolizing stone. For geomicrobiologists, this is not just a curiosity, it is a living analog, a model for how life might persist in the most extreme environments imaginable, including the icy, subsurface oceans of moons like Europa or Enceladus. Blood Falls is a crack in the door to a hidden world. It challenges our most fundamental assumptions about the limits of life, proving that even in the deepest freeze, under crushing pressure and total darkness, biological ingenuity can find a way. This crimson waterfall is more than a geological oddity. It is a message in a bottle from a lost sea, a profound reminder that life, once established, is tenacious, creative, and full of surprises we are only beginning to understand. Even the planet's most ancient legends can find a modern home. In the vast, sun-scorched emptiness of Turkmenistan's Karakum Desert, a new myth burns with a primal ferocity. This is the Darvaza gas crater, known more dramatically as the door to hell. It is a colossal pit, over 200 feet across and nearly 100 feet deep, and its floor is a churning lake of fire. Flames leap from vents in the crater walls, casting a flickering, infernal glow across the surrounding dunes that can be seen for miles in the dead of night. The heat radiating from its rim is intense and palpable, a wall of dry warmth that pushes you back. Its origin is not a mystery of deep time, but of a very recent human mistake. In 1971, Soviet geologists were drilling for natural gas when their rig hit an unexpected cavern. The ground beneath it collapsed, swallowing the equipment and creating this enormous sinkhole. Fearing the release of dangerous, uncontained methane gas into the atmosphere, they made a decision they believed would be temporary. They set the crater on fire, expecting the gas to burn off in a matter of weeks. That was over 5 decades ago, and the fire has not gone out. While its spark was lit by human hands, its enduring life is a purely geological phenomenon. This transforms it from a mere industrial accident into our final and most visceral, mysterious formation. The profound puzzle of the door to hell lies not in its creation, but in its stubborn, roaring persistence. It defies the expectation that such a vent would seal itself or exhaust its fuel. The mystery is the vast, hidden reservoir it tapped into. Energy geologists studying the site are monitoring a unique, large-scale gas seep event. The crater acts as a giant chimney, drawing a continuous flow of natural gas from a deep and seemingly prolific pocket within the Earth's crust. The burning itself reshapes the geology, as the intense heat cooks the surrounding sandstone, causing the crater's edges to periodically slump and collapse inwards, widening the maw and exposing fresh fuel for the flames. This creates a terrifying feedback loop where the fire actively maintains its own fuel supply. It has become a self-sustaining, accidental monument to a primal force. The crater defies natural explanation in its cause, yet its ongoing existence is a purely natural, if spectacular, process. It stands as a breathtaking and sobering testament to humanity's ability to accidentally unlock a power we then cannot control, a force we thought belonged only to the planet's deepest furnaces or our oldest stories. This eternal flame in the desert sand is a modern-day myth made real, a gateway to an underworld of pressurized gas, and a permanent, blazing question about the hidden energies that still slumber undisturbed beneath our feet. Our world is a gallery of impossible sculptures, each one a testament to the quiet, relentless creativity of natural forces. From the singing sands of distant deserts to the frozen crystals of deep caves, this journey reveals a planet far more mysterious and artistically inclined than we often assume. Each site, whether explained by delicate ice sheets or lingering chemical processes, pushes the boundaries of what we believe is possible. They are not errors in the system, but masterpieces painted at the very edges of the canvas, where the rules of physics and chemistry are stretched into forms of stunning elegance. These formations remind us that geology is not just a dry history of slow, predictable change. It is a living narrative of the improbable, the extreme, and the breathtakingly beautiful, written in the language of stone, fire, and time. These places defy simple explanation not because science has failed, but because they represent the outer limits of natural law. They are the rare moments where chance, material, and endless time conspire in perfect alignment to create something that feels, against all odds, like a work of art. A balancing boulder is not an accident, it is a monument to equilibrium. A perfect stone sphere is not a lucky shape, it is a lesson in patient symmetry. An eternal flame behind a waterfall is not a contradiction, it is a demonstration of persistent chemistry. As we reflect on these stones that balance, spheres that form, and fires that burn without end, let them inspire a deeper curiosity. The greatest mystery may not be in these distant, famous wonders, but in the hidden stories written in the landscape just outside your own door. What quiet defiance of the ordinary might be waiting in the local creek bed, the nearby cliff face, or the stone in your own garden? The earth is still writing its story, and every curious glance is a chance to read another line. If you were fascinated by these geological enigmas, We would love to hear which one captured your imagination most. Share your favorite in the comments below and subscribe for more journeys into the world's greatest mysteries.